So good morning to all. Is it audible, right? So we will start. So the next module which we have to discuss is introduction to ARM instruction set and the programs which we have to discuss. Okay. So this particular part you are going to have the programs for your lab also. So once I started with the half of the instruction set, so I will just go with the skeleton of your program, how it is going to look like, and the software which you are going to use in this particular programming is a kill. Okay, so kill compiler you are going to make use of. The help of the kill, you are going to write the assembly code. Okay, so now when it comes to the introduction to the ARM instruction set, okay, so let's see what are the different things which are going to follow. So the whatever the processor operations you are going to have, so they are going to have the operations. What will be the operation prior to the execution of by the processor, and what will the operation by an instruction after execution of the processor. So the processor operations using examples with pre and post conditions. Okay, so it will be having with examples with pre and post conditions. Next, we are going to have, it is going to describe the registers, pre and post condition, describing registers and what will be there inside the register, how the values will be stored in registers and memory before and after the instructions are executed. Okay, so we are going to discuss it. What is a pre before execution of the instruction, what is the value which is stored in the register, and after the execution, what is the value stored in the register, which is referred by pre and post. Okay, so now here one thing you have to keep in mind is, so whenever you are passing the direct value without having any suffixes or prefixes, then it is treated as a decimal number. But finally, the representation which your microprocessor will understand is hexadecimal value only. And after understanding in hexadecimal value, finally it is going to store it in decimal value itself. Okay, so it is nothing but what. So if you are going to have 20, for example, so if I'm going to store number 20 here, so if I'm going to store number 20 here, for example, now if I change this one to hexadecimal value, so what's the value you're going to get? It is 14. So now, so this 14, how it is represented? 0 into x. Okay, so 0 into x is the representation of the number in by hexadecimal. Similarly, if I want to represent this one with respect to the binary, then it will be 1 0 1 0 0, right? So this is a binary representation of your number 20. So 8 4 2 1 16. Okay, so but at the end you're having the b symbol. So this particular b which is there at the end, it will represent that whatever the number you are entering is a binary value. So this particular number, this particular representation is going to tell you that this is a binary value. Okay, so this particular, if it is having the beginning 0x, then it will be hexadecimal value. So this will be hexadecimal value. So this is hexa value. This will be if the end, if it is having b representation at the end, so then it will be binary value. Then it will be binary value. Okay, so that's what the representation is about, 0x and the binary with the prefix 0b. Okay, so at the end, if the b comes, then it is telling that it's a binary value. So if you have the prefix 0x in the beginning. So it is postfix, then it will be prefix. Okay. So the examples will follow this particular format. Whatever the example we are going to discuss here, so it is going to follow this particular format. So what is preconditions? It is nothing but before execution. So it is before execution. If you take the post condition, then it is after execution. So this will be after execution. Okay. So post condition is going to tell you that it is after execution. So now if you take the memory, how the memory is represented. So here the memory is represented as memory data size of address. Okay. For example, this refers to what? Data size of the memory starting at the given byte address. Okay. So for example, if it is memory 32 of 1024 means what? So it is a 32-bit value starting at address 1 kilobytes. Okay. So if you write M32, so that means what? So if you take the, for example, if you take the memory representation, so the memory representation will be what? The sequence of addresses. Okay. So it will be like this. So the memory will be stored. So the memory will be there like this. So starting from the address 0. Since it is a 32-bit, so it is going to generate the 32-bit address. So for example, it will be 0x0008 will be there since it has to represent with respect to 32-bit. So each which number is going to represent, since it is representation in hexadecimal, so that will be in, so each bit corresponds to an hexadecimal value. So now here, for example, what I'm telling is each memory location is going to consume 1 byte of data. So for example, if I tell you that, so normally what will happen, so when the memory is represented, so it will be, if it is 32-bit data, so you are going to have 0004070 followed by 4. Okay. So now what it means, so this, as it is indicating here, so the memory of 32, that means 32-bit data. So it is it is going to have the value from the address where it is going to have the value from the 1 kilobyte. So that means it is going to have from 1024 kilobytes address number 1024. But this particular 1024, what you are going to have, that has to be converted into hexadecimal, and in the, from that particular address, that particular value will be taken. Okay, that you have to keep in your mind. Okay, the whatever the 1024 is there, so that you have to convert to hexadecimal value first. So just I will show you using the calculator here. Okay, how to convert in calculator. So we are going to have this one. So I'm going to have 1024. So 1024, we are calculating in degrees radian. So we use scientific there. Okay, so it is going to convert your 1024 into hexadecimal representation. Okay, so hexadecimal, if I represent it, it will be what? 16. It I have to multiply it by 16. So it is 16, 6 are 96. So remaining is 64. 16 4s are. Okay. So 64H will be the answer what you are going to get. So 64H will be the 64 will be the representation for your hexadecimal. Okay. 64. So what you are going to get, it will be 0. So again, if I'm dividing it by 16, so it will be 16 4s are 64. Okay, so that will be again 0 you're going to get. So it will be 400. So this will be 400. Okay, so when you are representing your 1024 in hexadecimal value, the value which you are going to get is 0 into 400. So now here also, since the addresses are represented with respect to the binary value only, so your memory 32 of address is going to tell you what. So the whatever the value it is going to store. So that is 0000 5 zeros followed by 400. So this is hexadecimal representation. Okay. So whatever the memory address, it will be there inside your processor, that will be represented in hexadecimal value. So from here, the 4 bytes of data it is going to take. Okay, so that's what it means. So the memory 32 is the 32-bit value starting at the address 1 kilobyte. So, but 1 kilobyte we are telling with respect to the decimal, but when it representing with respect to the memory, so always the memory representation with respect to the hexadecimal value only. So first it is going to convert that one to hexadecimal value. So that is not converting, but for your understanding I am telling. So it I have to see the hexadecimal equivalent of the 1 kilobyte from where that particular data is going to start. Okay. So next, when you are going to have these values, so next, so ARM instructions process data which is held in registers and only access memory with load and store instruction, as I told you in the beginning only. So whatever the ARM instructions you are going to have, so the ARM instructions is going to process the data which will be held in the registers. Okay, so only instructions which will access the memory is your load and store instruction. The only access memory and only access memory with the help of the load and store instruction. Those are the two instructions which are used to load and store the load and store the data from memory or to the memory. So your load is the instruction what it is going to do. Load is the instruction which will move the data from the memory location to the register. So if we will see that one in the future, so how it is going to move. So how much data it is going to move from the memory to the register. So next is the store instruction. In the store instruction, what will happen? Store is the instruction which will move the data from the register to the memory. Okay, load is moving from memory to the register. Store is moving the data from the register to the memory. So if you take the ARM instruction normally commonly take 2 or 3 operands. Okay, what do you mean by operands? We will come to know. So that is nothing but it is ARM instructions commonly take 2 operands. So your operands are this one. It's nothing but this add. This is there, right? Your operands are nothing but your R3, R1, R2. So these are called as operands here. So R3, R1, R2 are called as operands. So now here, when you are going to have, we have to check that which will be the source operand and your add will be the instruction. So add is the instruction. Okay, add is the instruction. And your R3, R1, R2 is the operand. Okay, add is the instruction. Your R3, R1, R2 is the operand. Okay, now when it takes the operand, so it is going to have two parts. One is the destination operand and your source operand. So that means nothing but when you are doing some operation, either you should first you should know which will be your source operand and which will be your data where the source is present, and you should know where the destination is there. Okay, so for that one you are going to have. So if you take the normal example, add R3, R1, R2. So here your R1 is one of the source register. So source register R1, that is one data is stored in the register R1 and other register is stored in the register R2. Okay. So and the destination register is given by R3. So here you can see that your source register 1 is represented by Rn and the source register 2 is represented by Rm. Okay. So and the destination register is given by Rd. So once it is been executed, so once your instruction is executed, so what will happen here? Okay. So if you take add, that example I will take. So if you take the add R1, comma R2. So according to that particular example, R1, comma R3, comma. Otherwise, I will take R1, R2, R3 only. Nothing to worry about that one. Don't confuse with that one. Okay. So here, which are the source operand? Which will be the source operand here? Can you have the answer from your side?
R1 and R2. Sir.
No. According to this.
R2 and R3.
Okay. So your source operand will be R2 and R3. Okay. So these two will be your source operand. So this is one source operand. This is the another source operand 1, source operand 2. Now the final result what you are going to get is the destination which is R1. So after execution of the instruction, your R1 will be equal to R2 plus R3. So our R1 will be equal to R2 plus R3. Now here, one thing you have to find that this particular instruction is not having any suffix. Okay, any suffix is there. So the same instruction will be having the suffix add s. Okay, so the change in the suffix s is going to specify that add s, the same thing will be there. Add as R1, comma R2, comma R3. Okay, so here also the same. Your source will be R2 and R3. So your source operand will be R2 and R3. Where your destination operand is R1. The same way it is going to do it. Okay. So now, but what is the change here is whenever you have the suffix s at the end of the instruction, it is going to update the condition flags. It is going to update the condition flag. So as I told you previously yesterday that the condition code will be there. So that is NZCV, that is negative carry and zero flag, carry flag and overflow flag. So now if you have the S suffix for this particular instruction, it will update the condition code. So it will update the flags, update the flag we are going to tell, or so normally it will update the condition codes. So that means you are going to do the branch operation with respect to the condition code. So it will update the condition code. So it will update the condition code. Okay. So that's how the operation is going to take place with respect to the add instruction. So similarly, you're going to have the different set of instructions. So it will update the, if as yes is present, then it is going to update the condition code. So it is going to update the condition code. So this is how the add instruction is going to have. So next, when it comes to the introduction, let us see, that is one simple syntax we have taken for the instruction. Normally you have to keep in your mind that always load and store instructions are used to load the data from the uh, load is used to load the data from the memory to the register, whereas store is used to load the data, store the data from the register to the memory. Now, after seeing the instructions in your ARM will be having normally 2 to 3 operands. Okay, so ARM instructions which are you are going to use, it will be having 2 or 3 operands depending upon the type of the instruction. Okay, so now let us see what are the different types of instructions you are going to have depending upon the instruction class. So we are going to examine the function and syntax of the ARM instructions by instruction class. So now, if we take out the different types of instructions which the ARM processor is going to support is, first one is data processing instruction. First is a data processing instruction. Second is branch instruction. Third, load and store instruction. Fourth is software interrupt instruction. Fifth one is program status register instruction. So these are the five types of instruction which the ARM processor supports. So depending upon your instruction class. So you have to keep in your mind that there are 5 different classes. What are the different classes? Data processing instruction, branch instruction, load store instruction, software interrupt instruction, program status register instruction. Okay. So next, when it comes to the data processing instruction. So what do you mean by data processing instruction? So in the data processing instruction, what it will going to have is it is going to manipulate the data within the register. Whenever this type of instructions are executed, this type of instructions are going to manipulate the data within the register. So previously some data will be there in register, and after processing that particular instruction, you are going to have the change in the contents of the register. So in this data processing instructions, we are going to have what? There are more instructions will be there, and then you are going to have the arithmetic instruction. Arithmetic instruction is nothing but you are going to have the addition, subtraction, multiplication, division. Move is you are moving the data from one register to the other register. So next, you are going to have the data of logical instruction. As you know that logical instructions are nothing but which will be having OR and XOR. So these are the logical instructions which is supported by your ARM. Next is comparison instruction. When you are comparing the instruction, you are going to compare the 2 different operands. After comparing the 2 different operands, so that particular instructions will update the condition code. So depending upon the condition code, we are going to make use of the branch instruction depending upon the conditions. So next you are going to have the multiply instruction. So it is now here the multiply instructions are totally different compared to the arithmetic instruction. Now here when it comes to most data processing instructions, so one thing you have to keep in mind that so there in your ARM data flow model, core data flow model, we have discussed that barrel shifter. So there we have understood that the purpose of barrel shifter is to pre-process the instruction. Now here in the ARM instruction set, we will come to know that how it will be pre-processed. So what is the mechanism it will take to pre-process the instruction? Okay, so your most data processing instruction can process one of their operands using the barrel shifter. That means if we are going to have the data processing instruction, the data processing instruction will be having three operands. Okay, so that is it is two operands as source and one operand is the destination. Now here out of these two source operand, okay, one operand can be processed using the barrel shifter. The one operand which is there that can be used by used using the barrel shifter. Okay, that you have to keep in your mind. So we will discuss that how it will be used using the barrel shifter. Okay, that how we will discuss that how it will be used in the barrel shifter. Now next, as I told in the instruction, if we use the suffix s, okay, if you use the suffix s as a data processing instruction, what is it going to update? So I told you that it will update the condition code. So if an instruction if a suffix on the data processing instruction is there, it updates the flags in the CPSR. Okay, so you are going to have the flags or condition code in your bit, which one? 28, 29, 30, 31st. Okay, 31st bit in your CPSR field. Okay, so those flags bit or condition code bits are updated. Whenever you are using what? Whenever you are using the S suffix on the data processing instruction, which you have discussed in this one. So you are going to have the S suffix, right? So if you have the S suffix, what it is going to update? It will update the condition code or it will update the flags. So it is going to update the one is update the condition code. The other is it is going to update the flags in your CPSR register. So it will update the flags in CPSR register. Okay, so it will update in CPSR register. That is current process status register. Now, move and logical operations. Okay, move and logical operations. What flags it is going to update is the next question. So we will see by taking the values how it will be updating the different flags. So here, for a time being, we are telling that the move and logical operations which you are going to perform. It will update what are the flags it is going to change. It is going to update. It is going to update the carry flag. It is going to update the negative flag, and it is going to update the zero flag. So your logical data transfer data processing instruction is not going to update your which flag now? Overflow flag. Okay. So the carry flag is set from the result of the barrel shift as the last bit shifted out. Okay. So what are the things you have to keep in your mind that when your carry flag will be set? So here you can see that the carry flag is set from the results of the barrel shift. The carry flag is set from the result of the barrel shift as the last bit shifted out. So if in the barrel shifter, if the last bit, if it performs any of the operation, in that particular operation, if the last bit is shifted out, that means if you are doing the shift operations, for example, logical shift left operation when you are doing, so if the last bit is shifted, then also the carry flag will be set. That means. So here the end flag is set to bit 31 of the result. Okay, when you shifted out, the end flag, that is negative flag, the negative flag bit is 31 of the result. So the zero flag is set if the result is zero. So if the when it is shifting the operations, what will happen? So when the shifting is operation, if all the corresponding bits which are having one are shifted out, what it means, the remaining bits which are there will be having only zeros. then your zero flag will be set. So what that means? So now if we take the example of that one, you can see it here. For example, if I have shift left operation, for example, okay. So for example, if I have the shift left operation, so I will show. So now when you are shifting it, so since already you know what are the different shift operations you have come across in your organization, I think. Okay, the same thing applies here also. So if you are shifting the data, I am taking the example of only 8-bit here. So, but what is the size of the bit in your, how much bit will be there in your ARM instruction? How much bit it is going to support in your ARM instruction? In answers from your side? How many bits your ARM instruction ARM is going to support? What's the size of the register in your ARM?
32.
Yeah. So the size of the
Two.
size of the register in your ARM processor is 32-bit. So for your understand, I cannot write 32-bit here, 32 places here. Just I am showing it for 8-bit. Okay. So don't confuse with that one with respect to the ARM. It's only for your understanding purpose I am showing. Okay. When you are doing, assume that I have 1 0 followed by zeros. For example, I have these particular values 1 followed by all zeros. Okay. Now when you have this one, if I am shifting the left by 1 bit, so what will happen? This will shift it out. Whatever the value is there, so this particular value will be shifting to here. Okay. So here it will be 0 0 0 0 0 0 0. Okay. So now this value is shifted to this particular place. This particular bit is going to shift to this particular place. This bit is going to shift to this particular place, and just this one, this particular place, this will be shifted to here, and the bit which is vacant will be filled with 0. Okay, when you are doing the shift left operation. Now, what is the result you obtained now? The result which you have obtained is 0. The whatever the bits are there, the corresponding bit in that particular register is 0. So when you have 0 means what? Your 0 flag will be set to 1. Your Z flag which is there in your CPSR register, that will be set to 1. Now you can see it here, it is MSB. Okay, so it is MSB. So the MSB bit is 1, it is shifting out. So since the MSB bit is 1 and if it is shifting out, your carry flag bit will also become 1. Understood? So since your MSB bit is shifting left by 1, okay, the recent shift, so your carry flag bit will be 1. So how it will be thinking? So whenever the last bit it is going to shift, if the last bit shifted is 1, then it is going to set what? Then it is going to shift the carry flag. Now when it comes to the negative flag, so negative flag, whether it will see into the bit 31st. So this is considered as 31st bit. Okay. So since I am not writing here, you have to assume that remaining all zeros will be there. So from where to where? So if you take, so 24, 24, 0 to 24, assume that it is 0 only. Okay, it is, I am taking the illustration of 24 to 32. That's it. So 25 to 32. Okay. So there's 8 bit, 25, 26, 27, 28, 29, 30, 31, 32. Okay. So 31st you can take. Okay, 31st we are going to take. So now here, since we don't have the any values here, after the shifting left operation, the value which is there and the MSB bit is 0. So negative flag will also be 0. So now with this particular type of operation, since the result obtained is 0, your 0 flag will be set to 1. Since the last bit mode is 1, so the carry flag will be 1. Since bit 31st is not having 1 there, if it is 1 is there, then it is going to tell you that it is a negative number. Since 1 is not there, your negative flag will be 0. So now in your data processing instruction, what it is the limitation? We are not checking with respect to the overflow flag. So we are not checking with respect to the overflow flag. So it is overflow flag is not considered in your data processing instruction. So next, when it comes to the next type of instruction. So in your data processing instructions, the first instruction which you are going to have is move. Okay, so move is the instruction. So if you take the syntax of the instruction, so you can see it here, syntax. So in the syntax, what will happen? So you are going to have the instructions, right? First is the instruction type. What is that instruction? Either it will be a move or move in. Okay, I will come. What do you mean by move and move in? So next is the condition. So the condition means depending upon certain condition, if it is met, that is move equal or move not equal or move higher. So move not higher, move negative, move carry generated. So those conditions, if it is there, if any conditions is there, I'm going to make use of the condition. Next, if I want to if I want to change if I want to change the condition code, that means if I want to update the list, update the flag status, or if I want to update the flag bits in your CPSR. So you have the CPSR, right? Current program status register. Inside the current program status register, if I want, after execution of that particular instruction, if I want to change the contents of the flag bits, then you have to use the suffix RD. Okay. So now here RD stands for destination register. So you can see it here. RD stands for the destination register. Okay. N is your source. So where the N stands for the source, where RD is your destination register. So if you take the syntax for your data processing instruction, so how the syntax look like? First is the instruction, which is mandatory. Then it is a condition, whichever the uh, part which is having inside the flower bracket, it is not mandatory, it is optional. Okay, so now you can see that your condition is in within the flower bracket. So whenever you are going to have this particular type of options there in your instruction syntax, then it is optional, it is not mandatory. So depending upon your requirement, you can use it. Okay, if the requirement is not there, you are not supposed to use that one. So these two are optional. So condition is optional and your S is also optional. So S is used only if you are only if you want to update the flags in your CPSR register. Condition is used when you want to perform the operation depending upon some condition. When you want to that is like when you are going to have the branch instruction or conditional codes, your conditional instructions if you are going to have. So when you are going to have that type of instructions, you are going to make use of the condition code. Okay. So now after that one, your move instruction will be having the two operand. One is our source operand, that is N, and other is your destination operand, which is RD. So now in the move instruction, you can see that what is the move instruction is doing. So if I take only move R1 comma R2, for example. So even I can move the operand, your source operand may be in the register and the source operand may be a constant value. There are two types which you are going to take. So whatever the value you are going to store inside the register, destination register, the source data can be in either one of the register or the source data can be in one of can be a constant value. So I can say it here. Okay, so your source can be either register or M, or it may be a constant preceded by hash. Okay, so the example of your move instructions is nothing but what? The move instructions take the contents of register R5. If we take this particular example, so here you take the move R7 comma R5. Okay, initially the value of R5 is 5 and the value of R7 is 8. Okay, so now when you are going to have, this is pre-execution of this particular instruction. That means before execution of the instruction move R7 comma R5, what are the values which are there in R5 and R7? The value in R5 is 5. The value in R7 is 8. So now when you have this one, after having the move instruction R7 comma R5, okay, what it is going to do? So it is going to move the contents which is there in R5. It is going to move the contents which is there in R5 to R7. Okay, so it is going to move the contents R5 to R7. So that's what it is going to do. So if you after execution of this particular instruction move, after execution of this particular instruction move R7 comma R5, what will happen? Your R5 will also be 5, but it will not change the contents of R5 because it is a source register. Now, to which register it is going? It is going to the destination register R7. So your R7 will be value which was previously 8, which is previously 8. Now it has been replaced by the value 5. Okay, that's what it means. So previously it is 8. Now it is changed to 5, the value of the R7. So that is what it is going to do. So if we are going to have the constant value, for example, so if you are going to have the constant value, if you have the constant value, how it is going to make? So that is move instruction, move R7, comma, ash 30. Okay. So this is nothing but what? Decimal value 30. Okay. So this is a decimal value 30. It is moved to R7. But when you are moving the R7, what value it is going to represent inside the R7? What I told, how it will be represented inside your register? The value which is represented inside the register will be in terms of bits only. So if it is representing in terms of bits, the value which will be represented inside your register is hexadecimal value only. Okay. The value which will be represented inside your register will be hexadecimal value only. Now can you tell what will be stored in the R7? If I am moving the 30 to the R7, what will be stored in R7? What value will be stored in R7? Any answers from your side?
30 only, sir.
No, this is a decimal value. Okay, 30 is the decimal value. But what it is going to do, 30 only it will be storing, but it will be in hexadecimal representation. Okay, so can you tell what is the hexadecimal representation of 30? What is the hexadecimal representation of 30? So it will be what? 16. 1s are 16. So what is the remaining you are going to have? 14. So 14 you are going to represent it as what? A, B, C, D, E. So that will be 1.
1
E.
is, sir.
Yeah. So now it is how it will be represented, 1E. So that means in your R7, all it will be converted to binary equivalent. That is 0001. So that is 0001. So E is 14. That is 1, 1, 1, 0. The bit how it is going to store. And this is the hexadecimal equivalent, and it will be stored in 30. So now move R7, 30 or move R7, hash, okay, 0x1e, and then another instruction, move R7, hash. So this will be 0, 0, 1, 1, 1, 1, 0b. Now can you tell that whether all these three instructions are same? Whether it is moving the same value to the register R7?
Yes, sir.
Okay. So why? Because
Yes, sir.
so you can see it here. In the first instruction, I am moving the decimal value to R7, but internally into the register, it is representing with respect to hexadecimal as 1E only. But here I am moving 1E directly to R7. So here also the same value I am moving, but the same value, if I represent with respect to the binary, so 1E, that will be in this particular form. The same value I am moving it to R7. So now all these three instructions will be moving the same value now. Okay, your R7 contains the same value, that is 30 only, decimal equivalent. So but when you see the contents of the register, when you are doing the programming, how you are going to say it, you are going to we are seeing that what value it is going to be stored, it is 0 into 1E. because we can see it there that 0 into 1e is the value which you are going to have. That is hexadecimal representation. Because inside your register, it will be stored in the form of the binary. The binary value is represented in terms of hexadecimal value. So that you have to keep in your mind. That is one thing which you have to keep in your mind when you are doing the programming. Because all your answers, what you are going to get, it will be in the hexadecimal value only. So there you should not get confused. When you are adding 30 plus 20, it is 50. But it won't be, it will not be showing the 50 as the answer. But other than 50, what it will be showing as the answer? What it will be showing as the answer instead of 50? If you are adding the two decimal number, what it will be showing as the answer instead of 50? 50 is a supposedly decimal value, but it will in the register it will not show the 50. What it will be showing? What value it will show in your register?
Binary value.
Hexadecimal value.
Yeah, hexadecimal value. So it will show the hexadecimal equivalent of the 50 in your register. Okay. So finally, whatever you are going to see in your register value is hexadecimal value. So that you have to keep in your mind when you are doing the programming. Okay. So this is very important with respect to the programming. So this you have to keep in your mind. So this is where most of the students
So
will get
what is
confused.
X?
X is, it is to represent the hexadecimal value 0x. Okay, when you want to represent the when you want to place the hexadecimal value, you have to have the suffix 0x. Then only it will tell you that the value what you are moving into the register is a hexadecimal value. Okay, this X specifies that it's a hexadecimal value. X specifies the value which you are moving is a hexadecimal value. Okay, so this is how you have to place inside your register when you are placing it. So it will be like this. Okay, 0x 1e, 0x 1e. Okay, so if you want to move hexadecimal value directly into the register, this is what the syntax you should have. That's why I told you here. Okay, so in the previous instructions we have seen that. So where we have seen, so you can see it here, right? So 0x. Okay, 0x you have to prefix it to represent what number? To represent the hexadecimal number. You have to prefix it what? You have to prefix with 0x. Okay, that I have told in the beginning only. So if you want to have the represent with respect to the binary value, you have to have the prefix 0b. It is not prefix, it is a postfix. At the last we have to tell. Okay. So then we will see in the later all this experiment. So this is one instruction. Next is move not. So move in is the instruction. What it will do is move the not of the 32 value. That means whatever the value you are going to provide in your instruction, that will be complemented. So here you can see it is 5. So if you take the move in R5 comma R7 for example. So if you take move in so if you take move in for example R7 comma R5 is the example what we have taken there. Okay. So now here what will happen, initially the value of R5 is 5. So for that particular question, so here what will happen, 0 all 0 1 0 1 is the binary equivalent of 5. So remaining all are zeros, right? So remaining bits will be 0. Now what it will do is it will complement your 5. It will not complement only 5. Even the remaining bits it is going to complement it. So that means where to where it is from 0 to 32. It is 0 to 31. Okay, 31 bits will be there. So it will be complemented 0 1 0. Okay. Remaining all will be complemented to 1. Is because the values in that register will be remaining will be 0. Since the content the value which can be stored in the register is 32 bit, so it will be 32 bit. So 111 it will be having, another 111 it is going to have, like that. Remaining 28 bit it will be converted to 1 only. So now if I convert this one to hexadecimal, it will be 0x how many 7? 7, 7, 7 F's will be there. F, 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 F. So 0 and 0 is 8421. That will be 2. So this is how it will be stored. Any doubt now? Anybody having the doubt? If I execute this particular instruction, so here precondition is, if I take the with respect to the precondition, so your pre is R5 is 5. For example, if you take the and your R7 is 7, for example, post what will happen? Your post, it will not change the contents of R5. The contents of R5 will be 5 only, because the hexadecimal value and binary value for 5 is same. Okay, it will be 5 only, but the value of the R7, it will get changed. So you will see that when you are doing the programming. Okay, so the value of R7 will become what now? All that will be in hexadecimal value, which is 0x FF. So FFF 7F2. Okay. Any doubt in this one? Anybody having any doubt? Hello? Have any doubt?
No, sir.
Okay. So this is how the move instruction is going to work. So it is going to do the complement of the register. So whatever the value which is there in R5, so when it is before moving to R7, the value of the R5 is complemented. So after complementing the value of the R5, it is going to move that particular complemented value into R7. So that is what the move n instruction is going to do. Okay, your move n instruction is going to do the complement operation, as you know, the complement of n. Okay, not of n. Not is nothing but complement. So if the 1 is there in that particular place, it will convert that particular bit 1 to 0. If 0 is there, wherever the 0 is there, it will convert that particular, it will complement that particular bit 0 to 1. So that is how your data move n is going to work. So next, tomorrow we will see that in the next class we are going to see how you are going to make use of the barrier shifter. Okay, how we are this particular data processing instruction is done with the help of the barrier shifter. Okay. So any doubt till now? If anybody is having any doubt, you can ask.
Sir, explain R7 once more. Sir.
This one, huh?
Yes, sir.
Okay. So now here you can see that move n. Move n is move the negative number. Now move not. That means whatever the value is there in R5. Okay. So here precondition is pre-execution of this particular instruction. Register R5 contains 5. Your R7 contains 7. Okay. Now, when you have this particular value, what will happen? So the 5 is represented in binary with respect to this, because the register is how many bits in size? 32 bit. The register will be 32 bit in size. So 5 will be there, 0101. Remaining will be 0. Okay, remaining bits will be 0. Now, before moving to R7, what it will do? It will do the not operation. That is, it is going to do the complement operation of this particular value. So wherever 1 is there, it will replace with 0. Wherever 0 is there, it will replace with 1. Again, 1 is there, it will replace with 0. And here 0 is there. From this particular place to 31st bit, all are zeros. All will be converted to 1 only. Understood? So now, if we each 4 binary values represent 1 hexadecimal value. So 4 ones represents F. If I do the operation, because all apart from these first 4 bit, okay, first 4 bit, okay, first 4, so 0, even this will also get changed, 5, okay, this is also getting changed. So that means it will be 8421, that is 13, A, B, C, D. So it will be FFFD you are going to get, okay. Just make a correction in it one, because even 0 is there, that is also converting to 1 only. So that is 1010, that is not B. 842. 842 10. 10 means A. Okay, FFFA you are going to get. Okay, so that's what it is going to execute. So there you make a correction, here is it is A. Any doubt now? So after execution of this particular instruction, your R5 contains 5 and your R7 contains FFFA. Anybody having any doubt now? Any doubt?
No, sir.
Okay, so that's all. So we'll see how the barrel shifter works in the next class. Okay.